Hi, my name is Emma Reeves, and this December I attended the American Geophysical Union Fall Meeting, a week-long science conference in San Francisco. I'm a senior physics major with mathematics and geology minors at Hamline University. Last summer, I was able to participate in an internship through the Center for Remote Sensing of Ice Sheets, or CRESIS. We had a 2-student team and 2 mentors from Pennsylvania State. We spent 1 week at Pennsylvania State training on how to do our work, and the rest of the time at our base in Elizabeth City, North Carolina. On Sunday, December 8th, I flew into California to begin the meeting. The lectures, presentations, and events were held in 3 buildings. Moscow North and South opposed each other, while the large Moscow West was around the corner. The Marriott Marquis also served as a social gathering place for evening events. Groundbreaking scientific research was presented in the form of posters, oral sessions, and lecture presentations. There were 2 poster sessions every day for 5 days of the week. This picture shows only half of a room. With over 22,000 attendants at the conference, it is easy to imagine the multitude of scientific research. Our research studied radar profiles of the Northeast Greenland ice stream on the Greenland ice sheet. Using these airborne radar cross-sections, we were able to determine isochrones, which are distinct layers of resistivity that mark a point in time. The isochrones determine cross-sectional area bands, or flow bands. We used the ground GPS velocity data with the flow bands to determine the increase in flux in the upper regions of Neges. We also found a rapid temporal widening of the stream's margins in the radar profiles. These facts indicate that there is ice crossing the margins in the upper regions of the stream, where it widens. This could be a concern for the future stability of Neges. Throughout the week, I got to check out some other interesting research that combines physics and earth science, including the energy spectrum of waves, modeling of seismic waves in the earth, monitoring of microseismic noise, and using ambient seismic noise to determine structures of the earth, modeling acoustic propagation and its uses, and looking at wave dynamics in the ocean. Every year, seismologists and geophysicists from around the world come to attend the Gutenberg Lecture. This year it was given by Dr. Michael Ritzwaller of University of Colorado on the USA Array, an array of portable seismometers spread across the contiguous United States. Following is a short clip of his lecture.
Who says, at the end of his textbook, the data must be greatly amplified and strengthened. So it seems appropriate if today's talk will focus on one of the ways our generation has greatly amplified and strengthened the data, which is, of course, by the US Array. Of course, the results from ambient noise agree with results from earthquakes. So these are maps of ambient noise, Rayleigh wave phase speeds from ambient noise and earthquakes at 28 seconds period, and the similarities between the structures are, of course, striking. Now, I'd like to talk about methods that have developed for determining phase speeds across North America using US Array. The technique that I'm going to be talking about is called iconal tomography. So this is an observed travel time field from ambient noise for the 16-second Rayleigh wave across US Array. Again, in this particular case, centered at station SPMN, St. Paul, Minnesota. We can consider the travel time as an integral along the ray path of phase slowness. And simply by the fundamental theorem of calculus, we can undo the effect of the integral by taking the gradient. So locally taking the gradient of the travel time field with each central station, we can get an estimate of the magnitude of the phase speed. Okay? And that's what we've done here. And I just want to point out that if we're going to get a glimpse of the universe's soul, as seismologists, we're going to need more US arrays. Thank you very much.
While at the conference, I encountered my mentors and the principal investigator of the CRESIS summer program, Dr. Darnell Johnson and Dr. Linda Hayden. They gave a presentation on engaging minorities in STEM education, which I was fortunate to watch, and I also got to see some of their students' posters at the poster session. I also attended the networking reception for early career female scientists and students, where I spoke with women about their career choices and the challenges they have faced. I got to speak with a master's and PhD candidate from the University of Southern California, and also a postdoctoral associate from Oak Ridge National Laboratory. This event was hosted by the AGU president, Carol Finn, who is a research geophysicist for the USGS, co-hosted by Margaret Leinen, the AGU president-elect and director for the Scripps Institute of Oceanography. My last night in California, I went to the Union Square to see San Francisco at Christmas time.
To San Francisco, you're gonna meet some gentle people there. All those who come to San Francisco.
I want to thank the AGU Student Travel Grant and especially Dr. Bruce Bolin and the Hamline University Physics Department for funding me on this awesome opportunity. I recommend attending a science conference for any undergraduate students.